Okay, so you just watched the video about how to apply the law of sines. I'm going to walk you through example 2. We have 3 sections of it. We're going to walk through all of it. So with example 2, letter A and B are asking us to solve the following triangles, and we're going to round all our answers to the nearest tenth. So when you solve for a triangle, it means that you are going to solve for all sides and all the angles. So every single one of them is going to have an answer when we solve. And it's really important that if you didn't do in the law, if you haven't already, you make sure that your calculator, we want to make sure that our calculator is in degree mode. Is it in degrees, not in radians? Those are really, really important to know what you're doing. So what we are going to do is draw a triangle. Now this triangle is not going to be to scale. I draw the same triangle every time. It's just a way to keep track of our data. I'm going to have obtuse angles where there's acute angles and vice versa, but I always draw this triangle. It looks like this. It's not the right triangle that I draw every time. It helps me know that it's oblique or different. I'm going to label my angles. Remember, angles are uppercase letters, so those are all uppercase letters. Angle A is 32.0. We're going to change this. We're going to change this to 32.8, and we're going to change angle C to 21.9. We just missed that those were rounded wrong. We want this stuff to the 10th. So 32.8 is angle A. Angle C is 21.9. I'm going to start writing out angle A, angle B, angle C, side A, side B, side C, so that I can keep track of all my data. You only need to write down what you're missing, but this helps me keep track of everything. So angle A, it was given to me, it's 32.8. Angle C was also given to me, it's 21.9. Whenever I have a third angle in the triangle, I can solve it by doing 180 minus angle A, 32.8, minus angle C, 21.9, and that will give me 125.3. I'm going to go ahead and plug that in. Then it also tells me that side A, so remember side A corresponds with the one across, so side A is going to be 200 meters. So I have that one in. Then I have side B is going to correspond with being across from angle B, and side C is going to be across from angle C. I don't know what sides B and C are, but I can use the law of sines to solve for them. So I'm going to use A that I already have. I'm going to put 200 meters over the sine of 32.8. Then that is going to be equal to side B over the sine of 125.3. So what I'm going to do is multiply both sides by the sine of 125.3. So times the sine of 125.3. That means that B is equal to 200 times the sine of 125.3 divided by the sine of 32.8. When you put that in your calculator, you will see that side B is 300.3 meters. Now I need to solve for sine C. I could use the information I did for B, but I'm going to go back and just use what I used for A. So I have 200 over the sine of 32.8 is equal to, that's all for side A, and sine of A is equal to side C over sine of C, which is 21.9. Now, because you guys know we're trying to clear this denominator, so what we're going to do is move it over here, and we're going to multiply. So I'm just going to shortcut, not short circuit, the multiplication on both sides by just making that arrow. It just means that I'm going to multiply both sides. So then I get C is equal to 200 times the sine of 21.9 divided by the sine of 32.8, so that side C is equal to 137.7 meters. Now make sure that you are pausing the video and putting it in your calculator and making sure you're getting the same answers for that, because you don't want to get to your homework and not get it all wrong because you had it in the wrong mode. So we really want our calculator in degrees. Okay, now we have example B. We're doing the exact same thing. We're solving for our triangle. So I draw the same triangle. I have capital A, B, and C for our angles. It gives me A, which is 102.3. It gives me B, which is 27.8. I have angle A, I have angle B, I have angle C, I have side A, side B, side C. Now I can fix that. That's a little, yeah. So angle A was 102.3 degrees. Angle B was 28.7 degrees. Angle C is 180 minus 102.3 minus 28.7. It's going to give us an even 40, or not even, but no points, no tenths in there. Then it tells me that B is 27.4, so side B is 27.4. We did that in green last time, so we'll make this guy green. Angle A was purple. So, or side A was purple, and then C was pink. Just trying to keep it relatively the same as what we did before. So this time we have side B, and angle B is our corresponding things. So make sure you get that the side is 27.4 and the angle is 28.7. I messed that up my first time and flip-flopped them, and then I didn't get the right answer. Then we're going to have side A divided by the sine of angle A, 102.5. We're going to take this, multiply it over there. So we get A is equal to 27.4 times the sine of 102.5 divided by the sine of 28.7. We throw that in our calculator, we get that side A is 55.7. Oh, it says feet here, so I'm going to go ahead and add feet to A and B. Now I'm going to solve for C. We are going to use the same setup for B that we used before. Side B is 27.4. Angle B is 28.7, so sine of 28.7 is equal to angle C, which is 49 degrees. I should have put that in my triangle. Oh, nope, Miss Stone, that's not how you do it. That is what goes there, but side C over sine of 49 degrees. I hope lots of you caught me, but I did that wrong. Then we take this. We're going to multiply it through, so we get C is equal to 27.4 times the sine of 49 degrees over sine of 27.7 degrees, which if you put in your calculator, C will give you 43.1 feet. All right, now you do not have a very clear picture here, so when I was doing it and it was in the grayscale from what I printed, hopefully you can see a little better than what I did, but this is what the picture looks like, and then it's going to explain it to us. So a pole tilts towards the sun at an 8-degree angle. So this little angle is 8 degrees. Then I take the 8 degrees plus the 90 degrees, which is going to make this 98 degrees. Okay, then it says it casts a 22-foot long shadow. That's our C value down here is labeled as C. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So I don't know if you could see that in your picture, but it was indicated that this angle A right here is our 43 degrees. So I can see that my side is C, so that I need to figure out what goes with the angle that goes with this side. So I do 180 minus 98 minus 43, which gives us that this angle up here is 39. Then it says, how tall is the pole? So that is A, and A is across from angle A, So we're trying to find side A. We don't need to solve for side B because it's not asking me that. So this time I only need to solve for the one thing. I am going to set up my ratio. C is the side and the angle that I have, so I'm going to start there. So 22 degrees, let's write that. So these two match. The 22 feet goes with 39 degrees. So I have 22 feet over the sine of 39 degrees. And I want to solve for A, which I made red in this example. So we have A over the sine of 43 degrees. And we're going to take sine of 43 and multiply it to both sides to get A is equal to 22 times the sine of 43 degrees over the sine of 39 degrees, which if I put in my calculator is equal to 23.8 feet, because our shadow was in feet. So make sure that when you're doing your homework, you're showing all of this work. We want you to set up the ratios. We want you to show what happens after it multiplies and then get your answer. So you'll want to show your work on every single problem, and that's how you do this lesson. We'll see you when we're back.